going to show the percent composition of each element within the C3H6 molecule. The formula for that is you get the mass of each element divided by the total molar mass of the molecule times 100. So the mass for C3 would be 12.03 times 3 because you have 3 carbons, and that would equal 3603. And for hydrogen, which you have 6, so you would multiply 1.008 times 6 would give you 6.048. And the total of the molecule, the molar mass of the molecule would be 42.078. So to find the percent composition, you would just divide 36.03 divided by 42.078 times 100, which would give you 86%, and that's for carbon. So the percent composition for carbon would be 86%. And then for hydrogen, you would divide 6.048 divided again by the 42.078 times 100, which would give you 14% hydrogen. And if you add the 86 and the 14, it should give you 100%. Question number 2, you have 34.6 grams of the molecule C3H6, and it's asking you how many moles do you have. So all you do is you convert the grams to moles. So you would start off with 34.6 grams of C3H6, convert to moles. So then the molar mass of the C3H6 is 42.078 grams of C3H6, which is 1 mole. All you do is divide, which would give you 0.822 moles of C3H6, and that's about it. So that would be your answer. Okay. Question number 3 asks, what is the empirical formula of C3H6? So all you would do is use that same molecular formula of C3H6 and just find the ratio of C to H, which is for every 1 carbon, there's 2 hydrogens. So you just reduce to the simplest form, which would give you the empirical formula of CH2.
Okay. For question 4, we're going to draw the molecule and figure out what the geometries are in reference to carbon and if they're all the same. So to start, you need to figure out your valence electrons, and carbon has 4 valence, and then there's 3 carbons, so that's 12. And then hydrogen has 1 valence, and there's 6 of them, so that's a total of 18 valence electrons. And we'll start with drawing the 3 carbons. And then we need to figure out the hydrogens. And then, so this gives you a total of 2, 4, 6, 8, 10, 12, 14, 16 electrons, but we need 18, so we're going to put a double bond in between the carbons to satisfy all of the octets. And then it is not symmetrical because of this double bond and the extra hydrogens over here. And then since it's not symmetrical, it is polar. So we have 3 carbons, so 3A, and 6 hydrogens, so 6A. And then 2 oxygens, 2B, 1. Okay, so now I have to do it algebraically. So A is going to equal 1. So 3A equals 1C, making C equal 3. And then 6A equals 2D. So 6 times 1 equals 2D divided by 2. D equals 3. And then 2B equals 2C plus 1D. And we said that C equals 3 plus 3 equals 2B. 6 plus 3 equals 9 divided by 2 equals 4.5. So now I have to multiply all the numbers by 2. To get even numbers, so it would be 2 and that's your balance equation. Okay, for question 6, we're going to be given 34.6 grams of C3H6 with 19.6 grams of O2, and then we need to figure out how much CO2 and H2O we can produce. So to start, we have to find our limiting reactant and our excess reactant. And so we're going to start with our molecule, 34.6 grams of C3H6, and that is 42.078 grams of C3H6 for every 1 mole. And then from here, we need to look at our balanced equation from the previous question and figure out that 2 moles of C3H6 is 9 moles of O2, and for every 1 mole of O2, there is 32 grams, which gives us a final answer of 474 grams of O2. And so we were given 19.6, and so we have an excess amount of O2, which makes C3H6 our limiting reactant and O2 our excess. Okay, so now that we found our limiting reactant, which was C3H6, we can figure out how much CO2 and H2O that we can make. So we're going to use the same numbers, 42.078 grams of C3H6 for every 1 mole, and then 2 moles per 6 moles of H2O, and for every 1 mole of H2O, there is 18.015 grams of H2O, and that equals a total of 178 grams of H2O. Now that we've found how much H2O we can make, we're going to find how much CO2 we can make. And so we're going to use the 34.6 and then 42.078 for every 1 mole, and then 2 moles for every 6 moles of CO2, and then 1 mole equals 44.01 grams of CO2, which gives you 434 grams of CO2.
In question 6, which is the limiting reactant, C3H6 or O2? Which of the following remains? Okay, so in the last question, we were given that the amount of oxygen was 19.6. And so therefore, after solving the grams of C3H6 into grams of O2, we see that we have an excess amount of O2, as we have 474 grams of O2, meaning that this is an excess amount, making C3H6 a limiting reagent. How many sigma bonds that C3H6 has? And so it has 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore you have 9 sigma bonds. Alright, so now we're going to try to figure out how many pi bonds that this molecule has. And so we see that C3H6 has 1 pi bond. Alright, so we're on question 9, and it says, does C3H6 have any polar bonds? Are any of them polar enough to be ionic? So right here we have the charge of polarity for both carbon and hydrogen. Carbon has a polarity of 2.5 and hydrogen has a polarity of 2.1. And so what you want to do is subtract the polarity between both of the different atoms. And so you get a polarity of 0.4. And so because you have 0.4, this bond is polar, because the polarity range from 0.4 to 1.7. All right, and since it's 0.4, it's polar, but it's not polar enough to be ionic because it's barely polar. Alright, so for question 10, it says, what is the hybridization of carbons in the C3H6 molecule? Are they all the same? So in this molecule, we are focused on the 3 carbons. And so we're going to start off with this first carbon. And from this carbon, we can notice that there are three atoms connected to it. And so there's there's 2 hydrogen and 1 carbon. And so using the orbital sequence, we can identify that there is a sp2 orbital sequence to this carbon because there's 3 atoms connected to it. So it's using the 1, 2, 3 orbital sequence. And then for the second carbon, there's also 3 atoms connected to it. And so this is going to also be using the sp2 orbital sequence. And so for this last carbon, there are actually 4 atoms connected to this carbon. And so we're going to be using the 1, 2, 3, 4 orbital sequence, which just makes this carbon an sp3 sequence. Okay, and so since we can tell that there's a difference between these 2 carbon atoms and this carbon atom, this molecule is not the same.